Okay, hello and welcome to this case walkthrough. Today we're looking at a case called Wabble, which is based on kind of similar to the very well-known popular tile word game Scrabble. And this is from the MEWC 2024. I think it was the last 128 round. So just for comparison, something I've been trying to do recently is kind of work out what the live scores were for people who attempted this at the time and then compared with my own score when I attempted it for the first time. So I think it's this one here. So if I'm right, then straight away you did get people solving the whole case 1250 points in the time that was available, but then lots of people not getting above 1,000. So for anything over 1,000 would have, I haven't run the exact numbers, but certainly would have been in the top half of people competing in this case. So so probably would have been good enough to qualify, depending on who you're up against, because it's obviously a direct 1v1 fight in this part of the tournament, which I'm yet to experience myself, but I'm hoping to do that this year. So this case, the first time I tried it, I did get over 1,000. It's the first case I've done of these that I managed to get through all the levels. I didn't get it all right. I think I made some mistakes on level 6, but I was quite happy with that, but didn't get through all the bonuses. So it's certainly not close to getting it all right. And particularly the final bonus, I would have got completely lost on until I kind of had an epiphany later where I realized, oh, there's actually a simple way of doing that last bonus. But anyway, I'm going to do my usual walkthrough. I'm going to try and use the keyboard as much as possible, trying to minimize my mouse usage. I'll do a little bit of commentary as I go. And as always, I've done this case a few times now. This is not how I would have done it the first time, although some things are similar. This is how I would do it, knowing what's coming up and trying to do it as quickly and as efficiently and as neatly as possible. So yeah, that's enough introduction. Let's get started. So let's switch over to our score sheet, which is here, and we've got 30 minutes on the clock. We won't need that. This will be quite a relatively quick one. Let's start the game, and off we go. Okay, so first thing I'm going to do is we've got a words list here, so I'm going to select all of this, Alt F3, and I'm going to give this the name words because we're going to use that a lot. And also in the points section, I'm going to take these two, Control Shift F3, and I'm going to name the ranges. So I've now got a range called tile and a range called points. We've got the board on the next level. We don't actually need to name that. We can just kind of use indirect to call into that, which we'll do later. So let's get on to solving the case. So the first question is, are these words in our words list? So I'm going to import my lambdas here, and I'm going to use the if exists this word, didn't put an equal sign, so if exists this set of words here in the words file, then we want to return the word yes, otherwise we want to return the word no, and we get our answers there. Let's copy those over to level 1 and we get our 40 points. Okay, going on to level 2. How many points do each of these letters score if used in a word? So we can now use an XLOOKUP. Our XLOOKUP works on a range, so we're looking up these letters in our tile range, returning the points, and that gives us the scores, and we can put those into our score sheet and we get 100 points. So we're on to level 3. Okay, level 3, we're going to start building out our model using a data table. So we're now given words and we need to work out the number of points per letter and check whether the word actually appears in our words list, and if it does, then we get the points. So first thing we're going to do, just to be on the safe side, we're going to put everything into uppercase, because we might not always have uppercase. We actually need to know the length of this, not so much in this question, but in later, but I'm going to build it in now. So we're going to take the length of that, and then we want to know what the characters are. So the characters, I could use text characters, but actually I'll use mid just because it's nice to always just remind yourself of how these lambdas work in case you ever need to use them in a way that isn't standard. So that's actually, didn't spell the word sequence correct, so actually creating the length there is helpful. Then we want to know the values of these. I'm going to use capitals because I like it for neatness sake. So what we did on level 2, so we look up these in the tile and return the points, and then we want to know the sum of these, which is just going to sum that reference there. Then we need to know whether it exists, so is the word actually in our exist. So again, I won't use exist, let's use is number x match the value in E1, E4 in the words list, and that gives us a true or false. And then our final outcome is if that is true, then we return the sum, otherwise we return 0. And then we point to that for our data table. And we get our answers, and quite a few of them are 0 because they don't actually exist in the word list. So if you didn't know anything, you could just probably put 0 for all of them and you'd probably get about half the marks. Anyway, so that's level 3. Level 4, we start to build a bit more complexity. So we're now given part of the table, although it's given to us, so we don't have to look it up in the actual board. And we have to apply these double words and double letter scores as well. So let's create a new data table, but then let's grab our workings from level 3 so we can just build this incrementally. So what we're going to do is we're going to add a column here for our tiles, and what I'm going to do is I'm going to call a take from b1 hash, and I want the last 7 columns because that's going to be the last 7 spaces. And then what we want to do is we're going to have a multiplier, so we're going to say if this equals DL, then it's a double letter score, so we'll have a multiplier of 2, otherwise we'll have 1, and we'll multiply that by our original value. So on some of them we get double, some of them we don't. But we also need to check whether it is a double word. So we need to sum the number of times that our tiles equals double word. And in this case we get 1, and then we're going to have a second multiplier, and we're going to say if our multiplier is greater than 0, then we want the multiplier times 2 because it doubles it, otherwise it's just 1. And then our final answer is going to be, it's actually not this finish it because that's still pointing, that sum here needs to be pointing at this. And then our final answer is 98. And we'll take our values and we'll copy them over to our score sheet for level 4. Oh, I put that in the wrong cell. There we go, 140 points. Okay, moving on to level 5. So this time we're given a word, but we're now given a cell location and direction, and we need to work out what this would do in the board. So we can still build on our previous model. So we'll create a new data table, go to level 4, grab our entire model, go to the equivalent column in level 5 and paste that there. And we see we're getting some errors because our tiles are now looking at something that's different. So let's delete that, and we need to work out what are the tiles. So let's build this down here. So we're going to start with an indirect, and we're indirecting into the board sheet, which is just the word board with an exclamation, and then we're referring to cell C1, and then that just points into the actual cell, but we want to get a range, so we're going to then wrap that inside an offset. And what's the offset? Well, we're not actually moving the cell, but our range is based on the size of the word. So we need a range of the length and columns, and that gives us a square. And then we need to work out whether we're going down, so whether we want this first column or whether we're going across. So let's build this into an if function. So I'm going to say, in fact, let's call this our range, and then we'll say if D1 equals down, then what we want to do is we want to take the range and we want to take the first column. Otherwise, anything else we're going to take from our range and we're going to take the first row. And when we close that, in this case we get the column, but in the cases where that's actually a row, so if I change this to something else, see if I can find one, we actually still want it to be a column, so we'll just wrap that whole thing inside to col. Let's set this back to our example. So now I'm going to copy that whole formula and I'm going to put it up here, and then everything else should just run off that. So because that's all we've changed is where we get that information from. So yes, the answer comes out to 44. So let's reference that, copy those over to our score sheet and paste them in the correct row this time, and we get all the points. So we're now on to level 6. So level 6, we're now given a word and we're asked to find out what's the best location to put it in. So this time, this is where we need to make a little stop because this is slightly different to previous. So what I'm going to do is I'm going to go to my level 5 and I'm going to turn all my model here into a lambda that we can then apply, because what we're going to need to do in level 6 is basically vary the input cell and directions, and try all the different combinations until we get the best score. So let's start by setting these 3 inputs as input cells, because for each one we have a word, a cell and a direction. And this over here is our output. So we go to that cell and we say generate a lambda statement, and it's going to create a formula that takes our whole model, and we're going to rename each of these inputs. So the first input is the word, the second input is the cell, and the third input is the direction. Press OK, press OK. We've now got our lambda, and we're going to say, I'm going to assume that's all good. So we're going to say save lambda as, and we'll give it a name and we'll call it word value. Okay, and now we can go to case, back to the case, we can create data table for level 6. That's all very wide because of that example 7 setup. What we're going to do now is we are going to firstly find out the length of the word. So the length of B1 is 5. And now I want to get all the cells that we could possibly use, and they tell us that we can't. So if we have a word of length 5, we can't put that down here and go down because there's not enough space. So we kind of need to shrink this board, and we need to basically remove 4 rows and 4 columns because our word can't go in those places. So the way I'm going to do that is I'm going to just call this keep, and we're going to say that -1. And then what I'm going to do is I'm going to refer to the column headers of the board. So I'm going to take that information and I'm going to take the row headers and just return all of those. But then what I want to do is I'm going to wrap this inside a drop, and I want to drop -4 rows and -4 in this case columns. Okay, so those are all the starting cells we could actually use, and then I'm going to wrap that in a 2-col so we get it all in a nice row. So those are our possible tiles. Now we could potentially, if we had a 1-letter word, have 225 starting locations because it's a 15 by 15 grid. So we're just going to make sure our formula here goes all the way down to 225 positions, because this number, this size of this range will change. We've got 2 different possible directions, which is down and across. So we're going to use our word value lambda we just created. We're going to use toast as the word. I'm going to fix that location. The cell is here, and we're going to fix that based on the column, and then the direction is here, and we're going to fix that based on the row, and that's going to give us, in this case, a value of 20. And we're going to wrap that in an if error, because sometimes it's not, when we drag this all the way down, when there's not a cell, it's going to give us an error. So we're going to fill that to the right, and then I'm also going to go all the way to the bottom of my this, and then I'm going to fill that down. We get values, and that if error becomes important here, so we get those zeros, because all we need is the maximum of all of these. And in this case it gives us 60, which we know from the example is correct. And let's take our values, go to our score sheet, and on level 6, and there we go. Okay, that's all correct. So we found out the best place to put these words. Now we move on to level 7, where we're given a set of tiles, so a board, and we have to work out what's the best possible word we can, or best possible score we can get. We don't have to worry about tile positions and double words, but we have to think about all the possible words we can find. So for this, I'm going to create a new data table. It's being a bit slow because my data table for level 6 was quite data intensive, so I'm going to actually just clear that out to speed things up. I might just quickly clear the other ones as well, just so we're not, or some of them. So we need to know all the possible words we can find from this. So the way I'm going to do this is I'm going to basically use the combinations lambda to basically take, so combinations, I'm going to take an array which is, I'm going to text split the word, and then I'm going to take how many selections from that. In this case I'm going to take 7. I want to keep them in order because it's about the words in order. So when I do that, I get all the possible combinations. I'm now going to wrap that inside a by row, and the function I'm going to use is concat, so basically join those into single text strings. So we've now got every 7-letter combination, of which there are nearly 5,000, or there are more than 5,000. Now we could have shorter words, so we could have 6, 5, 4, 3, even 2-letter words. So what I want to be able to do is fix this formula here to point always to the word, and then drag it across, and we get that. And we find that actually the shorter the words, the less possible combinations there are. So there are only 42 2-letter words, then there are 5,000, or not words, but permutations. So what I want to do is I'm going to stack all of those together into a single array, because what I'm then going to do is see which of them can be found in our words list. So I'm going to restack those into a single array. Then what I'm going to do is I want to check whether they exist. So if I was just doing this on a one row basis, I would say exists this item in the words list, and it'll give me a true or false. But I want to do it for every single one. So I need to wrap this in a by row, going over K4 hash, that entire range. I'm going to use a lambda. For each row, I just want to check whether that row's entrance exists in the words list. And then that gives me a list of true and falses. And now I can use filter to filter the list of possible words against the ones that actually are words. And what we get is this list, which is only 52 long. Okay, so these are all the words that actually exist. And now I'm going to do this a similar thing again. I'm going to go by that row using a lambda. For every row, what I want to do is use my word value based on the word, and then I need to still give it a cell and direction, but because I don't want to do anything with any double words, whatever, I'm just going to put a cell down here, so a cell that's way outside the board, so that it doesn't get confused. So I'm just going to put Z26, which I know is outside of the range, and I'm just going to put down as the direction, but it doesn't really matter because there's no tiles out there. And then we get a score for each word, and then I'm just going to take the maximum of all of that range, which in this case gives me 28, and I'm going to make that my lookup, and it's going to be a little bit slow because it's got to go through literally thousands every single time of combinations, so a few thousand calculations. So I'm going to copy that over to my score sheet and paste that, and we've got it all correct. And then I'll come back here and I'm going to clear out that data table just so we're not slowed down with our calculations for the bonuses. So bonuses, we shall go. How many animals can you find inside the text strings in levels 1 to 6? I'm going to create a new sheet. I'm going to use the case questions lambda, and I want to know how, and I want to grab all these words. So I'm going to just copy that all as values only. I'm actually going to get rid of all of these that I don't need, and then I've got all my words, and I need to grab the animals list. So I'll just grab that from here. Again, I'll copy that as values only. And what we have to be careful is we've got fox and ox, so they both appear within the word fox, so that this one needs to return 2. So let's use that as our example. So what we want to know is is it a number when we search these terms here, and let's fix the location within this text string, and it returns 2 trues and the rest are falses. So what I'm going to do is I'm going to wrap that. I'm just going to put minus minus in front of that, and then sum that, and we get 2 there. So if I drag that both up, for most of them it'll be 0, but dogs, the word dog is inside dogs, so we get 1. So I'm going to select that whole column, and we see that there are 5 examples. How many bonus spaces on the board? So if we go to the board, and if we just, let's use the mouse for this one of these cases where mouse is definitely quicker, there are 30 things in there, so that's 30 bonuses. How many times does the most common letter appear in the list of words on the words tab? So let's go to the words tab. Let's get a alphabet list. So alphabet. And then what we want to do is we want to count the occurrences of this letter within the words list. And that gives us all of them. So 2, 2, 2, lots of 2s and 3s. And then what I'm going to do is wrap that inside a sum. And then I'm going to fill that down. And I've still got that range selected, and the maximum score is 18242. 18242. What is the total face of all the letters appearing in the case? So then I'm going to go back to my spare sheet. I'll use the case questions again for level 1 to 7. I'm then going to just check, I'm only ever interested in this first column. So let's just copy that as values over here. We can then delete that. And then what I want to do is I want to concatenate all of that range. Then I want to text split it, so using text characters on that. And the question was all total point score. So we then X look up all of those letters in the tiles, return the points, and then sum that range. And we get 3662. which we'll put in here. And then with all the bonuses, what is the highest score you can achieve by placing any word on the board using any set of tiles from any game in level 7? I didn't get to do this during my first 30-minute attempt. I looked at it afterwards, and my first thought was, let me just check, I've got plenty of time. Yeah, I've got 12 minutes to explain my approach on this. So I was thinking, right, I'm going to need to make a copy of level 7, and we'll need to, I was thinking, right, we're going to need to find every possible word, but we're also going to then need to try it against every possible location, because it might vary depending where the double word or double letter score falls. But then I had a closer look at the board and I thought, well, actually, what's the best place to place any 7-letter word? And there are some places where on a 7-letter word you can get 2 double word scores. There's no place where you can get 3 bonuses. So here, if we wanted these 3 bonuses, we'd actually need an 8-letter word. So we can either have double word and double letter, or double letter. So if the most we can ever have on a 7-letter word is a double word bonus twice, then actually we sort of already know the answer, because then in level 7 we found what was the highest scoring word, and that's without bonuses. So if the most bonuses we can have is double word, and 2 double words is better than a double word and a double letter, because every letter is getting doubled twice, if that makes sense. So double word is 2 double words are the best we can ever get. So actually we just need to go back to level 7. We'll just repeat our data table based on that cell, and we just need to find the top score, which in this range the top score is 42, and then we just need to times that by 4, because if we place that top scoring word in a double word, then that's what we'd get. So let's just copy those over to our score sheet, just double check that those are all correct. We just have to wait a few seconds because of the way the platform works, and there we go, all correct. Let's stop solving early. And what did we do there? Under 20 minutes. So yeah, so like I said, we know from the main draw, I think it was this round, that there were people who did that in time. As I said, this is the first case, proper MEWC case I've done where on my first attempt, under 30 minutes, I got through all the levels. Like I said, I didn't get it all right, because the mistake I made was on level 6, the model I'd built where I was actually copying this over, I'd forgot, for some reason I forgot, or I removed the check to see if the word actually existed. I'm not really sure why I did that, but on level, maybe I'd copied it from a level where, because it actually is used in all of the levels, but yeah, for whatever reason, I forgot to check whether it existed. So I gave the actual score, but for some of these, the word didn't actually exist in the words list, and so I should have scored it 0 instead of that. But yeah, so quite happy to actually get through all the 7 levels. I think I managed bonus 1, 2. So no, I didn't manage bonus 1. I attempted it but got it wrong, because I didn't do that thing about the fact that some of them double counted. So the word ox and fox there are 2 there rather than 1. So I got that wrong. I definitely got question 2 right. I think I got question 4 right. I didn't attempt question 5, and I think I attempted question 3, but I can't remember. But as I said, it meant that I did get over 1,000, which would have been a pretty decent score. So in quite a few of these rounds, that would have seen me progress through. So that's encouraging. I really like this case. So Harry Watson was the author. Really liked it. Yeah, lots of different skills were going on. I like the fact that you're building a model that then gets developed and added to. And it was one of the first times I've managed to use OA Robot in a case when doing it for the first time. There's been a few times now where I've used it afterwards to speed something up, but this was the first time I felt confident enough to go, actually, I think I can use this while the case was going on, and it meant I was able to get further than I would have done without using it. So yeah, that's enough chitter chatter. I hope you found that helpful. If you didn't, doesn't really matter, because I find it helpful to go through this preparation process of doing the case, both, the first time I do it under the timed conditions, and then go through it afterwards. I'm sure I haven't looked, but I'm sure there must be other walkthroughs of this which may have covered it in a better way. But yeah, thanks for watching. See you next time.